So let's summarize what we have learned about flex direction. Now, flex direction is changing the main axis of your container. You have four options, which is column. That means that your main axis is going from the top to the bottom. You have column reversed. That means your main axis is starting at the bottom and going up. You have row, which is going left to right, and you have row reversed, which is going right to left. Now, I mostly still tend to think about those as two options, which is row and column, basically, because this kind of fundamentally changes your perspective, and those others just kind of mirror it. So for me, in my experience, it's a little bit easier to think about them still as two, but if you prefer, just think about them as your four options. Remember that the default one for new elements in Unity is always column. Now, in a nice world, we would now be done, basically. We have learned our four settings. We can we understand that changing the axis changes the alignment of the items. And that's basically it. We can go to work. Now, unfortunately, the real magic of Flexbox only starts here, and a lot of other things are actually happening. Now, we can see that, for example, when we change our direction back to row, and now let's just duplicate this container. I will throw away this this dummy visual element that was only there for us to see the names. So we have two identical containers, and now let's just change the direction of the second container. And what you can see now is, sure enough, our items are aligned along the main axis, which is left to right here and top to bottom here. But there is more stuff happening, which is those container elements are growing somewhat differently, right? So the sizes of those elements are in a way different. Like the first container stretches left to right. It uses the whole width. Now, it uses the whole width because this green area here is just the margin. So the actual area is the stuff in between the green area. So you can see our container uses the whole width. Now, our second container, however, also uses the whole width and more height. So we might ask the question, for example, why is this bottom container not ending here, and why is this top container not ending here? And this actually brings us one step deeper into the Flexbox rabbit hole. What I mean by that is, unfortunately, the Flexbox world does not work in this sense where you have your nice container, you have your items, and you think about them. How do I distribute my items? And you understood everything. Now, the beauty of Flexbox is that it kind of has the ability to generate your layout with your elements kind of depending on each other. And so to understand a lot of behavior of your elements, it's not enough to actually look at the element. You also have to look at what element are they in. And you also have to look at the properties of the element that they are in. And then again, you will probably have more elements inside elements again. Then you also might need to look at what is this element in again. And that will only end when you reach some parent element, like your root element like we have here. But apart from that, you will always have this game of layouts of elements influencing the layouts of the children, or the other way around, child elements influencing the layout of their parent. And so let's just try to see this. This is kind of the first instance where we meet this behavior to understand why the sizes of those containers behave behave in that way, we actually have to take a look at their parent. Now, when we look at the parent, we see we have a visual element that is kind of covering our whole canvas, and that has a flex direction of column, so the default flex direction. Now, how does this influence the sizes of those elements? Now, by default, the rule is the following. By default, elements are kind of protecting their main axis. Now, what I mean by that is when we look at our container and we try to identify what is its main axis, now it has a direction of column. That means that main axis is this vertical axis. And now protecting its main axis means tell your child elements to just use as much space as they need on the main axis. And now that's happening here because you can see for our first container, it's using just this much space. This space around here is just some margin or some padding, I think. Now it only uses as much space as its children need, and the same thing goes for the second element. It also uses just as much space as its children need. So again, on the main axis, on the total main axis, like this, it says kind of don't expand. Use as little space as you need to fit in your elements. Now on the cross axis, however, the situation is different. As we can see, the cross axis of our main visual element is going like this from left to right. Again, forget about those gray areas. This is just the padding of this main element. Our main axis is going left to right, and sure enough, the two children that we have are allowed to use up the whole cross axis to expand. And this is the default behavior. We didn't set anything, any additional properties here, like the grow property. By default, elements kind of protect the main axis. That means don't expand on the main axis, but sure enough, you can expand on the cross axis. So again, don't expand on the main axis, expand on the cross axis. Or I just try to remember this by saying I'm protecting my main axis. I don't care about my cross axis. So don't grow on the main axis. You can grow if you want on the cross axis. And again, to understand the default size of those two items, it's not enough to just look at them. You have to look at their parent and the flex direction of this parent. Now, if you don't believe me so far, I will try to convince you a bit more by changing the flex direction of the parent. And now you can see what happens to the sizes of the elements. And let's see if this is kind of following our rule. We said we are protecting the main axis. Now the main axis now is left to right. It's going like this. Or if we want to restrict it to the width that we actually have, it's going like this. Or it's going longer, it's going like this. But you see, the elements are not expanding. They just use as much space as their children need. So those three and this one element basically. And on the cross axis, which is going like this, we can see that the two elements are allowed to expand. Now, technically, this is coming from one of the properties that we have under align, which is this stretch property here. But this is the default behavior for any new element that you add to Unity. And the simplest way, again, for me at least, to remember that is that I imagine that those elements try to protect the main axis and they don't care about the cross axis. And that means don't stretch along the main axis, but you can stretch on the cross axis. Here our main axis is horizontal. When we switch it back, our main axis now is vertical. And again, the elements are not allowed to grow on the vertical axis. They are allowed to grow on the horizontal axis. So this is just one of those instances, and there are a lot of examples like that, where you can see that only kind of imagining your flex properties like flex direction, and only learning, okay, in one case it's going left to right, in the other case it's going top down, will not be enough to actually understand all scenarios in Flexbox. And there are endless sorts of different behaviors that you can get with this kind of logic, where you can see that parent elements are influencing child elements, and so on and so forth. And that's basically the reason why Flexbox, at least in my estimation, is more of an art than something that you can just nail down and always have the right solution for, because you basically have endless combinations, and depending on how good you are and what you are trying to achieve, you can use those combinations of properties to your advantage or to your disadvantage.